ball bounces off of a wall when you cook from a recipe book when you know how much money you owe. That's mathematics.
Welcome back to Algebra on the Spot. Today our focus will be a review for our algebra test number 5. It's going to be on blog day this week. Looking at problem number 1.
Write the linear equation that describes the relationship between x and y in the table.
So we have a table of points, x and y. The linear relationship means write the equation. I'll abbreviate equation, EQN. So we're going to go to our calculator, go to our stat, and we're going to enter points and edit L1 and L2. Bree, if you'll read the numbers for me for the x coordinates.
Negative 4.
Mm-hmm.
Negative 1. 2. And 5.
All right. Now we'll go over to L2.
Which would be y. Negative 7. 2.
Just a moment. Okay, negative 7.
Mm-hmm.
2.
11. And 20.
Thank you. All right, once we've entered our points, then we go back to stat. We go over to calc. We go down to number 4, linear regression, and we press enter. And we have A is 3 and B is 5. A is 3, B is 5. 3 is our slope, and 5 is our y-intercept. And our equation is y equals 3x plus 5. So that's our linear relationship. Number 2.
Which equation is the parent function
for a linear equation? So we want the parent function, linear equation. Our first choice is y equals absolute value of x. We haven't done anything with absolute value functions, so that's not an option. Y equals the square root of x. We have not investigated radical functions. So our two choices, y equals x and y equals x squared. For a linear parent function from our last lesson, y equals x. Because y equals x squared is for a quadratic. Number 3.
What are the zeros of the function y equals x squared plus x minus 6?
Now notice when Bree read that, she said y equals f of x is the same as y. So I want us to change that to y equals x squared plus x minus 6. Very good, Bree. And we'll go to our calculator. In our calculator, clear that out. We go to y equals, and we type in our equation. X squared plus x, subtract 6. And we go to graph. Now from our last lesson, we learned that our zeros are the same as our x-intercepts, same as the roots. So we want to read the 2 points where our line or our parabola crosses the x-axis. Now we're in our standard window. This is our zoom 6. If we want to go in closer, let's do a zoom and 4. The zoom 4 gives us our 4, negative 4, 4, negative 4 window. Now we can read our points. On the negative end, 1 0 is negative 3. On the positive end, our 0 is positive 2. So our zeros then are
negative 3, 0,
and positive 2. Now we can also read our zeros from our table. So let's go to our table, second and graph. When we read the zeros from the table, we're looking for the 2 points where y is equal to 0. We know that one of our roots is negative, and here we have it. Y is 0, x is negative 3. We know the 1, 0 is positive, and here we have it. Y is 0, x is 2. So from the table, our zeros look like this. Negative 3, 0, and 2, 0. Problem 4.
Simplify 27x
to the third power.
to negative third power times y to the fourth power over 3x to the second power times y.
Okay, and if Bree will let me borrow the remote, I'm going to zoom in. Okay, better. So we can see the powers. Now, notice Bree said the negative third power. Awesome. Fraction bar indicates division. So we're going to divide. 27 divided by 3 gives us 9. When we look at same bases, we subtract the powers. Subtract. I use it. Well, I'll spell it out. It should be T-R-A-C-T. Subtract powers. So, you can't see it. Subtract powers. All right. So that gives us x to the negative 3, subtract 2 power, and y to the 4, subtract 1 power. Now we're going to simplify. So our answer here will be 9, x to the negative 3 minus 2, or negative 3 subtract 2 gives us negative 5. If you're not sure about that, type it into your calculator. We have the same sign, so our answer is going to be negative. And y to the 4 minus 1 is 3. Now that's one way our answer may look. Our next statement asks us to write your answer with positive exponents. Well, we only have one exponent that's not positive. That's the negative 5. When you have a negative power, that means that that power or that exponent is going to go into the denominator of a fraction. So here's my fraction bar. The only thing that will go into the denominator is the x to the negative 5 power. But when it goes into the denominator, the power is no longer negative, it is positive. So it goes from x to the negative 5 power to x to the 5th power. Everything else remains in the numerator. 9y to the 3rd power. Number 5.
Simplify negative, open parentheses, 3x squared y, close parentheses, to the cubed root.
Well, that's just to the 3rd power. Cube root would be to the 1/3 power. Thank you, ma'am.
You're welcome.
Notice the negative is not inside the parentheses, so it will not be raised to the 3rd power. So we'll bring our negative down. Now this 3rd power says we will write 3x squared y 3 times. I'm going to do a little scratch work out to the side. So we'll have 3x squared y times 3x squared y times 3x squared y. Remembering that we are multiplying. 3 times 3 times 3 gives us 27. 3 to the 3rd power is 27. X squared times x squared times x, forgot my square, times x squared gives us x to the 6th power. X to the 2 times 3. We multiply the powers when we raise a power to a power. Y times y times y gives me y to the 3rd power. Or y to the 3 times, and this is an imaginary 1. We don't see it, but we know it's there. Y to the 3 times 1. So our simplified answer would be negative 27, x to the 6th power, y to the 3rd power. Problem 6.